Earth's landmass can be roughly divided into 7 continents. Humans, animals, and plants are common on the other 6, but Antarctica stands out due to its perennially cold climate, with temperatures dropping as low as -60 degrees Celsius. Few creatures can survive such a harsh environment. Penguins, however, are an exception. They are found almost throughout Antarctica. So what qualities do penguins possess that allow them to survive in such harsh conditions? Penguins' feathers are structured into 2 layers. The outer layer, with its elongated, tubular feathers, is tightly packed like roof tiles, making it less susceptible to being blown away by strong winds. This characteristic is crucial, as Antarctica is not only cold, but also frequently experiences strong winds, sometimes reaching gusts of up to 200 kilometers per hour. If strong winds could lift a penguin's feathers, they would be unable to withstand the extreme cold. The inner layer, with its soft, fluffy feathers, offers excellent thermal insulation, similar to the filling in our down jackets. Scientists have found that penguin feathers are 3 to 4 times denser than similarly sized birds, meaning penguins wear several times more warm clothing than other birds. Furthermore, penguin feathers have a unique microporous structure that traps air and forms a thermal insulation layer. It is these unique feather properties that allow penguins to maintain their body temperature on land while still allowing them to hunt in the water. Even underwater, the water temperature remains very low. Without waterproofing, each dive would cause a sharp drop in body temperature, severely damaging the penguins. However, it's the characteristics of penguin feathers that allow them to maintain a body temperature of approximately 37 degrees C and function normally, even in Antarctic temperatures of -60 degrees Celsius. In addition to their feathers, penguins also possess a 3 to 4 centimeter thick layer of fat. This fat layer has 2 main functions. First, IT provides excellent insulation, a mechanism also relied upon by many marine organisms. And second, it serves as an energy reserve. After each dive, penguins consume large amounts of food, which is digested and stored as fat, allowing them to survive for extended periods without foraging. This efficient energy storage helps penguins adapt to the extreme conditions of Antarctica. This thick layer of fat is crucial for penguin reproduction. After laying eggs, female penguins return to the sea to feed, leaving the male penguin entirely responsible for incubation, which lasts approximately 2 months. During this time, male penguins must remain by the eggs, unable to leave, relying entirely on their stored energy reserves to survive. They consume this layer of fat to provide heat, ensuring the eggs remain warmed and incubating in the freezing cold. By the time the chicks hatch, male penguins have typically consumed nearly 90% of their fat reserves. This demonstrates the enormous physiological cost male penguins incur during the reproductive process, and their contribution cannot be ignored. In addition to fat reserves, penguins' circulatory system also possesses a highly efficient energy-saving mechanism. In most animals, arteries transport warm blood from the heart to the body, transferring heat while doing so. Veins carry cool blood back to the heart, requiring reheating during the return process, a process that consumes significant energy. However, penguin arteries and veins are tightly interwoven, forming a structure known as countercurrent heat exchange. As warm arterial blood flows to the body surface, some of this heat is directly transferred to adjacent venous blood, raising the temperature of the returning blood. This mechanism effectively reduces heat loss, particularly in the extremities of the body, such as the feet. Although less heat is transferred to the feet, penguins' foot tissues are cold-resistant and have low metabolic demands, allowing them to walk and stand normally. These are inherent physiological advantages possessed by penguins. But even more remarkable is their group behavior. When temperatures drop further, and individual physiological mechanisms alone are no longer sufficient to cope with extreme cold, penguins adopt a collective strategy for cold weather protection. Huddling together for warmth, they gather closely together, forming large groups, often called penguin balls. In this structure, penguins do not fight the cold in isolation, but rather rely on group collaboration to withstand the cold. Even though the outside temperature can drop to dozens of degrees below zero, the temperature at the center of the group can remain above 30 degrees Celsius. Even more ingenious, the group does not remain stationary, but rather rotates slowly in a clockwise direction. After enduring the cold wind for a period of time, The penguins on the periphery move inward, while those originally in the interior move outward. This rotation mechanism allows each penguin to take turns entering the warm center, avoiding prolonged exposure to the cold that could cause a sharp drop in body temperature. This not only safeguards individual heat reserves, but also ensures the survival of the entire colony. Without this dynamic rotation, penguins on the periphery would likely collapse from hypothermia within a matter of hours. It's precisely this highly collaborative survival strategy that allows penguins to survive in the coldest environments on Earth. This collaborative, cold weather proofing method is truly a miracle of nature.